If you look at the global energy charts from the year 2000 to 2020, you see a story of brotherhood. Solar and wind, the green twins. They grew up together. They fought the fossil fuel giants together. And the prediction was always the same: they would conquer the future together. But in the last few years, the twins separated. In 2023, the world added 50% more renewable capacity than the year before, the fastest growth rate in 2 decades. But if you look closer, that victory is almost entirely solar. While solar panels are being installed on everything from factory roofs to balcony railings, the wind industry is in a crisis. Major projects off the coast of New York and the UK have been scrapped. Manufacturers are losing billions. Turbines are failing faster than we expected. We are witnessing a technological decoupling. One energy source has become a piece of technology, behaving like a microchip. The other has remained a construction project, behaving like a bridge. Today we are going to explore why the sun is rising and why the wind is running out of breath. To understand why solar won, you have to understand Wright's law, often called the learning curve. It states that for every doubling of cumulative production, costs fall by a constant percentage. Solar is, at its core, a semiconductor. It is modular. Whether you need power for a pocket calculator or a massive city, the basic unit is the same: the solar cell. Because of this, we can mass-produce billions of identical units. And when you make billions of something, you get really, really good at it. In 2024, Chinese manufacturing flooded the market, dropping module prices to record lows, sometimes below 10 cents a watt. It is now the cheapest source of electricity in history. Not just renewable electricity, any electricity. Now look at wind. A wind turbine is not a module. It is a massive, bespoke piece of heavy machinery. You cannot print them on a circuit board. They require thousands of tons of steel, copper, concrete, and rare earth magnets. This creates a fundamental economic trap. Solar gets cheaper as technology improves. Wind gets more expensive when inflation hits. When the cost of steel and interest rates spiked in 2023, the cost of building a wind farm jumped by 40%. Solar shrugged it off. Wind got crushed. The wind industry tried to fight back with a strategy called Gigantism. The physics are simple. Bigger blades catch more wind. So they built them bigger, and bigger, and bigger. Today's offshore turbines are taller than the Eiffel Tower. But there is a limit to physics. We have reached a point where the machines are literally too big for our infrastructure. We are running out of ships that can carry them. We are running out of cranes that can lift them. There are only a handful of ships on Earth capable of installing the next generation of 15-megawatt turbines. These ships cost hundreds of thousands of dollars per day to rent. If the wind blows too hard during installation, the ship sits there. You burn cash. If a gearbox is missing, the ship sits there. You burn cash. Compare that to solar. You put it in a box. You put the box in a truck. You drive the truck to the site. 2 guys lift it out. Logistics kills projects. And right now, wind is a logistical nightmare. But it gets worse. In the rush to build bigger turbines to compete with cheap solar, engineers may have pushed the materials too far. In 2023, Siemens Gamesa, one of the world's biggest turbine makers, admitted to serious quality issues. Bearings were failing. Blades were showing wrinkles. The forces on these massive 100-meter blades are unimaginable. The tip of the blade is moving at nearly 200 miles per hour, slicing through rain, hail, and salt spray. It's like driving a race car through a hurricane non-stop for 20 years. This is the OBEX trap operating expense. Solar panels don't move. They have no gears. They sit there and harvest light. If a panel breaks, you unplug it and plug in a new one. Cost $100. If an offshore turbine bearing fails, you need a helicopter, a crane ship, and a crew of divers. Cost millions. Investors hate uncertainty. With solar, they know exactly what they are buying. With wind, they are increasingly worried they are buying a 20-year maintenance headache. And money hates headaches. For years, the wind industry had one ultimate defense, one ace in the hole. The sun doesn't shine at night, therefore we need wind to balance the grid. That was true. until the batteries arrived. Just like solar, battery prices are crashing due to the electric vehicle boom. Lithium-ion battery prices have dropped nearly 90% in a decade. We are approaching a tipping point where it is cheaper to build a massive solar farm plus a massive battery park to store that energy for the night than it is to build a difficult offshore wind farm. Once solar plus battery becomes cheaper than wind, the economic argument for wind evaporates. Batteries provide stability that wind can't. Wind is variable, but a battery is instant. It is controllable. It is the perfect partner for solar and a dangerous rival for wind. So, is wind energy dead? No, that would be an exaggeration. Wind will still play a crucial role in northern latitudes, places where the sun is weak and the wind is fierce, but the dream of the equal twins is over. Solar has won the war for the dominant energy source of the 21st century. The future isn't blowing in the wind anymore. It's soaking up the sun. What do you think? Are we giving up on wind too early, or is the maintenance cost just too high to justify? Let me know in the comments below.